Hi everyone, today's topic is dynamic memory allocation. If you all remember, we used to write in every program a statement called variable declaration where you used to write some variable declaration like this. So what happens here, we all learned that a is a variable and it is storing an integer value and more specifically value 10 here, and we discussed even the memory allocation being done there. So how much amount of memory is being allocated? 4 bytes of memory for integer value. Now, this memory is allocated during the compile time of the program itself. That means when you type the command cc space filename.c, then itself the memory is being allocated. But the problem you encountered with this compile time memory allocation is when we used to write a statement int a of 10, that is a is an array and it is holding 10 integer values. So 10 into 4, 40 bytes of memory is continuously allocated during the compile time itself. Now if you would like to store any 5 elements, remaining 5 elements memory is getting wasted. Now during the program, if you would like to store 20 elements, this 10 elements, 10 into 4, 40 bytes of memory is not being sufficient. So this is the main drawback of the compile time memory allocation. To overcome this type of to overcome this disadvantage, we have taken the concept of dynamic memory allocation. Means during the running of the program, the memory will be allocated. So the topic we are learning today is dynamic memory allocation. Dynamic means at the runtime of the program. Now, how can this memory allocation be achieved? Using some predefined functions called malloc, calloc, realloc and free. Actually, what are these 4 functions? These help us to achieve this dynamic memory allocation, and all these 4 functions reside in the header file called stdlib.h, header file. Now, before understanding the syntaxes of these 4 functions, we need to just revise our topic of pointers. I hope everyone know what a pointer is. How do you declare a pointer? We place an asterisk symbol before the variable name. Let us define what a pointer is first of all. A pointer is a variable that has the capacity to store an address of another variable. Now what is that variable? Suppose I have variable a. Now I have taken the variable a. Now what am I writing here? I am storing the address of variable a in pointer p. Now what happens with this statement is a is a variable, it will have value 10 and it will have 4 bytes of memory, and say some memory location, the starting memory location is 2002. Now this 2002 gets stored in p. Now how do you access that? Using a star before the pointer. We all know what a pointer is. Now, one more important point we have to remember regarding pointers is whenever we are trying to store the address of a variable, the pointer and that particular variable must be of the same data type. Yes or no? So, this is the main one point we have to remember. Now, coming to the void pointer. Void pointer is also called as generic pointer. In such cases, what happens? I have told that pointer and the variable's address which we are storing, both must be of the same type. Now, what can a void pointer do? Actually, what it points is, it can point to any type of data, whether it can be integer, whether it can be floating point or a character pointer, anything it can, any type of data can be pointed out by void pointer. Now see, now I am not declaring it to be integer, I am declaring it to be void. That is a pointer star ptr. Next, I am declaring a variable a and it is of type integer. Now what am I writing? Same memory allocation. I am storing the address of a in void pointer ptr. This statement is also acceptable according to the void pointers concept. Now how do you access value of this pointer ptr? Generally for normal pointers we can write star ptr, we will get the value 10. But what in case of void pointer? Now value stored at pointer is 10 has to be printed, right? So we will give format specifier %d. Now what is the pointer that is pointing the value ptr? We should not write star before it. We should not write star before it. We have to say that we want an integer pointer. We want an integer pointer. Means void pointer is converted to integer pointer for this statement only. Now, this entire statement refers to an integer pointer. Now how do you access a value at that pointer? You will place a star before it. Just once again, now PTR is a void pointer. Now you have to convert that pointer to an integer pointer. That's why I am placing int star before the pointer. Now how to access a value at that integer pointer? We have to place a star. So I hope everyone understood the difference between a normal pointer and a void pointer. So void pointer can access any type of data, but be careful while accessing it. We need to put a typecast. This is called as typecasting. You are converting void pointer to integer pointer at this statement, and you are accessing the value using a star before it.